All right, in this video, we're going to talk about section 2.6 dealing with differentials. And in this section, we're going to be finding and using increments in x and y, finding the differential of a function. Also, we'll compare increments in y to differentials and solving applications using differentials. All right, so here we're going to begin with increments. Now, already we talked about the definition of the derivative of f at x as the limit of a difference quotient. In this case, here it is, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, and the whole thing is divided by h. Okay, increment notation will enable us to interpret the numerator and the denominator of the difference quotient separately. So here's the definition of increments here visually. For y equal f of x, here we got delta x is equal to x2 minus x1. So that means that x2 will be equal to x1 plus delta x. And then we have delta y is equal to y2 minus y1. Now, in this case here, we can write that as f of x2 minus f of x1. And then that's going to be equal to f of the quantity x1 plus delta x minus f of x1. Since in this case, x2 is equal to x1 plus delta x. So here we just substitute the x2 with x1 plus delta x minus f of x1. Here, delta y represents the change in y corresponding to a delta x or change in x. As you can see in this picture here we got a graph of the function y equal f of x, and here we're going from x1 to x2. That distance is represented by delta x. Let's just say the horizontal distance is delta x, or change in x. This distance from f of x1 to f of x2, that distance is delta y, or the change in y. Okay. Now keep in mind that the change in x can either be positive or negative. Okay, so let's look at this first example, where, in this case here, we got for y equal f of x, which is equal to 7x to the fourth. We want to find delta x and delta y, and the change in y divided by the change in x, or delta x divided by delta y divided by delta x. And we're given that x1 is equal to 3 and x2 is equal to 5. So in this case here, we're going to start this problem off by, let's identify what delta x is. So as I mentioned on the previous page, delta x was x2 minus x1. And here x1 is 3 and x2 is 5. So if I find delta x, that will be 5 minus 3, which is equal to 2. Here I'm given x2 is 5 and x1 is 3. So delta x will be 5 minus 3, which is 2, or the change in x. Now we're going to need to find the change in y. Of course, the change in y would be y2 minus y1. Okay. Or we can say f of x2 minus f of x1, because y and f of x mean the same thing. So in this case here, we need to find out what f of x1 is and f of x2 is. And here x1 is 3, so we'll evaluate f of 3, and my f of x function is 7x to the fourth. So that means I'll just replace the x with with 3, so it'll be 7 times x is replaced with 3, that's to the fourth. And this can be done on the calculator if you like. So in this case here, I'm going to have, put this out, 7 times, and then 3, press the hat key, and then 4, and hit enter. That will be 567. So at x equals 3, f of 3 will be 567, not 564. All right, and now for f of 2, x2 is going to be 5, so that means we're going to evaluate f of 5. So that means there my f of x is 7x to the 4th. So that means I'll just replace the x with 7. Bring down the 7 and replace the x with 5. So it'll be 7 times 5 raised to the 4th. So 7 times 5, that's raised to the 4th. Then hit enter. And here you're going to get 4,375. 4,375. That's what f of x2 is, or f of 5 is going to be. Okay, so in this case here, we can find out what the change in y is, which is f of x2 minus f of x1. So in this case here, we're going to take that 4,375, subtract from it f of x1, which is 567. So if I subtract 567 from 4,375, this will be 3,808. So the change in y is 3,808. All right, and now we can find out what delta y over delta x is. That's the change in y divided by the change in x. So in the case here, the change in y, we found that out to be 3,808 divided by the change in x, which was 2. So 3,808, I'll take that answer and divide that by 2. That would give you 1,904. So the change in y divided by the change in x will be 1,904 as the answer. And of course, delta x, the change in x, is 2. Delta y, the change in y, will be 3,808. Delta y divided by delta x, that's the change in y, divided by the change in x, which is 1,904. So that's how we simplify that problem. All right, here's another example. Let's say you had y is equal to f of x equal to 2x squared. And here I want to find delta y, delta x, and delta y divided by delta x. And we're given that x1 is 2 and x2 is equal to 6. Okay, so in this case, we just do the same thing. Find delta x, which is, of course, x2 minus x1. And we're given that x2 is 6 minus x1, which is 2. So 6 minus 2 will be 4. Now, of course, delta y, or the change in y, would have to be y2 minus y1, or we can write that as f of x2 minus f of x1. So here we need to find out what f of x1 is and f of x2 is. Well, here, x1 is 2, so we need to evaluate f of 2. And my f of x function is 2x squared. So we have to replace the x with 2. So it'll be 2 times 2 squared. So using calculator will be 2 times 2. And then I'll press that x squared button to square it. Then hit enter. That would give me 8. So f of 2 ends up being 8. And then for f of x2, well, x2 is 6, so we're going to evaluate f of 6. So that'll be 2 times 6 squared. Keep in mind my function, f of x is 2x squared. So it'd be 2 times 6, and that's squared. That would be 72. All right, so now we can find out what f of x2 is minus f of x1. That's the change in y. So f of x2 came out to be 72 minus f of x1 that came out to be 8. So 72 minus 8 will give me 64. So the change in y, or delta y, will be 64. And from that, I can find out what delta y divided by delta x. That's the change in y divided by the change in x. Well, the change in y was 64 divided by the change in x, that was 4. So 64 divided by 4 will end up being 16. Okay. So delta x is 4, delta y is 64, delta y divided by delta x will be 16. All right, next we'll look at differentials. Assume that the limit f prime of x is equal to the limit as delta x approaches 0 of the change in y divided by the change in x exists. For a small delta x, f prime of x will be approximately the change in y divided by the change in x. And when you multiply both sides of this equation by the delta x, this is what you'll get. Delta y, that's going to be approximately equal to f prime of x times delta x. And here are the increments. Here the increments, delta x and delta y, represent the actual change in x and y. And one of the notations for the derivative is f prime of x equaling to dy over dx. Well, just dy dx, I should say, since it's a linear operator. If we pretend that dx and dy are actual quantities, then this is what we'll get. Dy is equal to f prime of x times dx. So here we treat this equation as a definition and call dx and dy differentials. And here delta x and dx are the same and represent the change in x. The increment delta y stands for the actual change in y resulting from a change in x. And the differential dy stands for the approximate change in y estimated by using derivatives. So here we're going to be using delta y, and that's going to be approximately equal to dy, which is equal to f prime of x dx. Now in applications, we're going to be using dy, which is easy to calculate to estimate delta y, which is what we want. So to summarize all of this, here's the information regarding that. If y equals f of x defines a differentiable function, then the differential dy or df is defined as the product of f prime of x and dx, where dx is equivalent to delta x. Now, in symbolic notation, we say this: dy is equal to f prime of x times dx. Or we can say the derivative of f or df is equal to f prime of x times dx, where dx is equal to delta x. All right, now let's look at some examples of just this. To put all that in perspective, let's first find dy in example 3. Here we got the equation y is equal to 26 plus 7x minus x squared. Okay. Now, if you're not good on these derivatives here, make sure you watch the video for section 2.5 that deals with some of the basic properties of derivatives, basic differentiation properties, I should say. All right, so here we're going to find dy. Now, we take the derivative of each term, since we got the sum and the difference here. The derivative of a constant is 0, so the derivative of 26 is 0. The derivative of 7x, that's just going to be 7 minus, when you take the derivative of x squared, we use the power rule by bringing the exponent in front of the x. So that 2 comes down in front of the x. And of course, that x will be to the 1 less power. So 2 minus 1 will be 1. So it'll be 2x to the 1 or just 2x. So dy will be 7 minus 2x, and then we include dx. And that 7 minus 2x, of course, is in parentheses. So that means that that dy would be equal to 7 minus 2x times dx. Okay. Now take a look at example 4. Right, if I can get to the page. There we go. All right, example 4 is this. Here we got y is equal to x cubed times the quantity 10 minus x divided by 5. Now, in this case here, we're going to have to use a distributive property because we have yet talked about what they call the product rule. We'll talk about that in a later video, but here in this case, we're going to use the distributive property here. So that means I'm going to bring down the y that's equal to distribute the x over the 10 and x over 5. X cubed times 10 will be 10x cubed. And then minus x cubed times x to the 5th. I'm going to write x to the 5th as 1/5. But when I multiply x cubed times x, I'm going to get x to the 4th. When you multiply powers of the same base, you bring over the base, add the exponents. So I have y is equal to 10x cubed minus 1/5 x to the 4th. Now let's take dy. Let's find out what dy is. Here we're going to take the derivative of each term here. So for the derivative of 10x cubed, I bring this exponent of 3 down, multiply it by 10. So 3 times that 10 in front would be 30. Copy over the x to the 1 less power. So it'll be 30x squared. And then minus the derivative of 1/5 x to the 4th, we bring the 4 in front of the 1/5. We multiply that 4 times that 1/5 will be 4/5. Copy over the x to the 1 less power. So it'll be 3. And all of this will be multiplied by dx. Okay, so dy then will be equal to 30x squared minus 4/5 x cubed, that quantity multiplied by dx. All right, here's another example. Let's say we had this. We want to find dy for the function y equal 885 divided by the cube root of x. Okay. Now I'm going to rewrite this using positive exponents here. And I'm going to rewrite the cube root of x in exponential form. The cube root of x, we write the x down. The exponent for the x is 1. That would be your numerator. Your index of 3 will be your denominator. So you have y equals 885 over x to the 1/3. But here I need to pull that x to the 1/3 out of the denominator. So I can easily use the power rule for this. So it'll be y is equal to 885. Take the x out of the denominator, but that 1/3 as my exponent will be negative. So I have y is equal to 885 x to the negative 1/3 power. Now we can find out what dy is. So if I take the derivative of 885 x to the negative 1/3, I bring the negative 1/3 down and multiply it by 885. So 885 times negative 1 divided by 3. That would be negative 295. and then copy the x over to the 1 less power. That means I have to subtract 1 from negative 1/3. So here's what I'm going to do. Negative 1 divided by 3, and I'm putting that in parentheses, minus 1. And then it has to remain as a fraction. So I'm going to press the math key. Number 1, it will be negative 4/3. And then dx. And I think they want this without the negative exponent here. So I'll write that as dy is equal to, put the negative in front, and then 295. And then the denominator, I'll pull the x in the denominator. That negative 4/3 will become positive 4/3. And then dx. So the dy is equal to negative 295 over x to the 4/3 times dx. Okay. All right, on the next page, let's find dy for, in this case here, y is equal to 9x plus 2 quantity square. In this case here, I need to expand 9x plus 2 quantity square. So off to the side here, I'll do 9x plus 2 quantity square. Then 9x plus 2 is used as a factor twice. So I'll write that as 9x plus 2 times 9x plus 2. And then apply the FOIL method. So here, 9x times 9x will be 81x squared. The outer would be 9x times 2, which will be plus 18x. The inside will be 2 times 9x will be plus 18x. Then last times the last, 2 times 2 will be plus 4. So when I simplify this, I'll have 81x squared plus 18x plus 18x is 36x plus 4. So y then will be equal to the 81x squared plus 36x plus 4. Now let's find out what dy is going to be using differentials. Your dy then would be, if I take the derivative of 81x squared, I bring this 2 down, multiplied by 81 will be 162. Copy the x over to the 1 less power, so the x to the 1 is just x, plus the derivative of 36x would just be that coefficient 36, and the derivative of 4 is 0, since the derivative of a constant is 0. I'm going to put this in parentheses because I had to tack on the dx. So dy then would be equal to 162x plus 36, and that quantity is multiplied by dx. Okay. All right, now let's take a look at example 7. Here we're going to find the indicated quantities for y is equal to f of x equaling to 5x squared. And there are 2 parts to this. In part A, you're going to simplify f of 1 plus delta x minus f of 1, all divided by delta x. And then part B, what does the quantity in part A approach as delta x approaches 0? Okay, so let's do this. We got a f of x equaling to 5x squared. So f of 1 plus delta x minus f of 1 times divided by delta x. All right, first of all, let's find out what f of 1 is using f of x equal to 5x squared. Well, f of 1, we just replace the x in that function with 1. So it'll be 5 times 1 squared. Well, 1 squared will be 1 times the 5 in front will be 5. And then f of x, 1 plus delta x, f of 1 plus delta x. That's just simply replacing the x with 1 plus delta x. So I got 5 times 1 plus delta x, and that's going to be squared. And in this case here, that 1 plus delta x squared, I can write that as 1 plus delta x times 1 plus delta x, since it's being used as a factor twice. Then we have 5 times this. We have to use the FOIL method. 1 times 1 will be 1, plus 1 times the delta x will be delta x, plus delta x times 1 will be another delta x, plus delta x, and that whole thing is going to be squared, because delta x times delta x is delta x and you square it. And if I simplify this, this will be 5 times 1 plus, I got 2 delta x's here, so that'll be 2 delta x plus delta x. That's going to be squared. Notice I'm putting the delta x in parentheses because the whole thing is being squared. Distribute the 5 over what's in the parentheses. You'll have 5 plus 2 delta x times 5 will be 10 delta x, plus 5 times delta x in parentheses, and that's squared. So that's what f of 1 plus delta x will be. So here, f of x plus delta x is this, so it'll be 5 plus 10 delta x plus 5 delta x, and that's squared, minus f of 1, which is 5. The whole thing is divided by delta x. All right, now if I simplify this, the 5's add to 0, 5 minus 5, that would give me 0, so that's gone. I'll be left with terms that have delta x in them. 10 delta x plus 5 delta x, and that's squared, divided by delta x. Now in this case here, I can factor out the delta x here because I have that in both terms in the numerator. So if I factor a delta x out, 10 delta x divided by delta x will leave me with 10, plus 5 delta x squared divided by delta x will leave me with 5 delta x. All that's divided by delta x. And we can divide out our delta x's in the numerator and the denominator. You'll be left with 10 plus 5 delta x. Okay. So this is part A. When we simplify it, it'll be 10 plus 5 delta x. So that's part A. Part B asks this question. What does the quantity in part A approach as delta x approaches 0? Okay, so that means we need to take the limit as delta x approach 0 of this. Which came out to be 10 plus 5x. So the limit as delta x approach 0 of 10 plus 5 delta x means this. As we let delta x approach 0, that means that 5 times delta x, we get closer and closer to 0. It's going to approach 0. So we're only going to be left with is 10. And that's what they're looking for here. So here, as delta x approaches 0, the quantity in part A will be approaching 10. All right, example 8. Let's say here, for y equal f of x equal to x to the fourth minus 8x plus 9, we want to find dy and delta y given x2 and delta x is equal to negative 0.1. Okay. So we already know that dy is equal to f prime of x times dx. dy is equal to f prime of x times dx. So in this case here, I'm going to bring down the dy. F prime of x, we need to take the derivative of x to the fourth minus 8x plus 9. For x to the fourth, we bring the exponent of 4 down, copy the x over to the 1 less power, so it'll be 4x cubed, minus, for the derivative of 8x, that would end up being 8. The derivative of 9, like the derivative of a constant, is 0. And this will be in parentheses, I'll include dx. Okay. And we're told that delta x is equal to negative 0.1, which means dx is negative 0.1. Yes. All right, we did talk about dx. That's also the same as saying delta x. If you remember, f prime of x dx, that means dx is going to be equal to delta x, the change in x. So if the change in x is negative 0.1, that means dx will be negative 0.1. Right. Now let's find what dy is going to be. So dy then will be equal to, in this case, you're given that x is equal to 2. Here it is, x is equal to 2. So we're going to replace the x here in 4x cubed minus 8 with 2. So it'll be 4 times 2 cubed minus 8 times dx, which is negative 0.1. So if I use my calculator and do this expression, 4 times 2, and that's raised to the third, minus 8, that would be 24. So here 24 times negative 0.1, that would mean dy will have to be 24 times negative 0.1, negative 2.4. So dy then would be equal to negative 2.4. Okay, now they also ask for the change in y, or delta y. And delta y, if you recall, is actually this right here. F of x1 plus delta x minus f of x. So minus f of x. This is f of x plus delta x minus f of x. That's actually that numerator in that definition of the derivative function. So now delta y would be equal to f of x, which is 2, plus the change in x was negative 0.1, minus f of x, or f of 2. Now let's simplify this a bit. Delta y is equal to f of 2 plus a negative 0.1 would be 1.9 minus f of 2. Now off to the side, we need to evaluate what f of 1.9 is and what f of 2 is. Okay, so for f of 1.9, we're going to use this formula, this function f of x, and just substitute each x with 1.9. So this will be 1.9 raised to the fourth minus 8 times x, which is 1.9 plus 9. Okay. So I had to do this in the calculator. Left parentheses 1.9, close parentheses, hat key, and then the 4. Right arrow to get out of it, minus 8 times parentheses 1.9, close it, plus 9. That would give me 6.8321. And then for f of 2, use that function, replace the x with 2, so this would be 2 to the fourth minus 8 times 2 plus 9. And using the calculator, it'll be 2 hat key to the fourth. 2 hat key to the fourth, right arrow to get out of it, minus 8 times 2 plus 9. That ends up being 9. So in this case here, delta y would be this. F of 1.9, that's 6.8321, minus f of 2, which is 9. So delta y would be 6.8321 minus 9. This would be negative 2.1679. So in this case here, dy is negative 2.4 and delta y would be negative 2.1679. All right, take a look at this next example here. Let's say I want to evaluate dy and delta y for the function below at the indicated values. Here you got y equal f of x equaling to 80 times the quantity 1 minus 8 over x. And here x is equal to 4. Dx is equal to, of course, delta x. And that's going to be equal to negative 0.125. Well, let's simplify what y is. I'm going to distribute this 80 over the 1 minus 8 over x. So 80 times 1 will be 80 minus 80 over 1 times 8 over x. That would be 640 over x. Now I'm going to write 640 over x using negative exponents here. So in this case here, this will be y is equal to 80 minus 640. Pull the x out of the denominator. It's a positive 1 in the denominator, but when I pull it out of the denominator, it'll become a negative. So I'll have y is equal to 80 minus 640 x to the negative 1. Now let's find out what dy is. So dy then will be equal to, well, for the 80, the derivative of 80, like the derivative of a constant, is 0. Bring down this minus, well, before I do that, for negative 648 x to the negative 1, if I bring the negative 1 down, that'd be negative 1 times 6, negative 640 will be a positive 640. Copy over the x to the 1 less power, so that means negative 1 minus 1 would be negative 2. And I'll go ahead and add on the dx. And also I'll write this using positive exponents, so it'll be dy is equal to 640 divided by x squared dx. Okay. Now let's go ahead and find out what dy is going to be. And here x is equal to 4. So for dy, I just substitute the x with 4, so it'll be 640 over 4 squared times dx. In this case, dx, which is the same as delta x, that's negative 0.125. So dy then would be equal to this. Using the calculator, I have 640 divided by 4 squared. Then that's going to be multiplied by negative 0.125, or negative 0.125. That ends up being negative 5. So dy then would be negative 5. And now let's find out what delta y is going to be. That's a change in y. And of course, delta y is always going to be f of x plus delta x minus f of x. So in this case here, delta y is equal to f of, my x is 4, so the f of 4 plus the change in x was negative 0.125 minus f of x, which is 4. And if I do 4 plus negative 0.125, this will be 3.875. So delta y would be f of 3.875 minus f of 4. Now let's evaluate f of 3.875. Using the original function, this will be 80 times the quantity 1 minus 8 divided by x, which is 3.875. And all of this can be typed in the calculator. So I'm going to do 80, and then left parentheses, 1 minus 8 divided by 3.875, close parentheses. Let's see, I'm not sure how they want this, but right, I do need to check to see. Yeah, to 2 decimal places. They want this to 2 decimal places. So in this case here, this will be negative 8.85.16. And then for f of 4, that would be 80 times 1 minus 8 divided by x, which is 4. Well, this is going to be easy. 8 divided by 4 would be 2, so it would be 1 minus 2. And then 1 minus 2 would be negative 1. Negative 1 times 80 would end up being negative 80. Okay, so now delta y will be this. Negative 85.16 minus f of negative 4, that's negative 80. So delta y will be equal to, and again, we can put this in the calculator, negative 85.16 minus negative 80 would be negative 5.16. So delta y ends up being negative 5.16. Right? So to answer that problem, delta y will be negative 5, and dy will be negative 5, but delta y will be negative 5.16. Okay. All right, now let's look at some applications dealing with differentials. This is the last example in this video. And it says here that an egg of a particular bird is very nearly spherical. The radius to the inside of the shell is 4 millimeters, and the radius to the outside of the shell is 4.2 millimeters. Use differentials to approximate the volume of the shell. Now, they tell you that the volume of the shell, or the volume of any sphere is this formula. V sub r is equal to 4/3 pi times the radius cube. Okay. Now, let's go and write this formula down. V of r is equal to 4/3 pi times the radius cube. And let's find its derivative. So V prime of r is this. 4/3 and pi are constant, so I'm going to bring those down. Now I'm taking the derivative of the volume with respect to the radius. So that means the derivative of r cubed, I bring down the exponent of 3 in front of the r, copy that r down to the 1 less power. So 3 minus 1 will be 2. And then I can simplify this just a bit. Here, these 3's divide out. So this will be simplified as this. V prime of r is equal to 4 pi r squared. So that means here, for my differential, using differentials, dv will be equal to v prime of r times dr. So dv, or v prime of r, I found that out to be 4 pi r squared. Then we tack on the dr. That's my differential here. Okay, so now we're going to find or approximate the volume of the shell. So that means here, we have a radius of 4. That's the radius for the inside of the shell. But now we got the radius to the outside of the shell, 4.2. So to find out what dr is, we need to take the radius of the outside to the outside of the shell minus the radius to the inside, which is 4. So 4.2 minus 4 would be 0.2. That would be what dr is. That's a differential for the radius, or the change in the radius, I should say. So here the change in volume would be 4 pi times the radius, which is 4, and that's squared, times 0.2. All right, so in this case here, let's say we use 3.14 for pi. So it'll be 4 times, I'm using 3.14 for pi, times 4, and then that's squared, times 0.2. And to 2 decimal places, this will be approximately 40.19. So dV in this case will be 40.19, and this is in cubic millimeters. And I say that because the volume is going to be in cubic millimeters. Okay. Okay. Now here I use an approximate value for pi. But for the exact value, I think they want the exact value so that way you can get a correct answer here. Let's do this. I type in the 4 and then the time sign. For the pi, that's right above this hat key. So you have to use second and the hat key for the pi, times 4 and then squared, times 0.2. And then hit enter. Yeah, that's what they want. So it'd be 40.21. Okay. So it'd be 40.21 cubic meters. Okay. Again, on your calculator, to access pi, you have to press second and then the hat key, because right above the hat key, you're going to see the button that says pi. Okay. So second half of the pie. All right, so that does conclude this video on section 2.6, dealing with differentials. Please feel free to email me or contact me if you have any questions about any of the problems that were presented in this video, or if you have questions about the homework that's in my math lab for this section.